Okay, so notes 22 is over the graphs of quadratic functions. So we have a couple blanks here on the concepts, so we can write down the different forms of a quadratic function. So the first form we have is f of x. Let me zoom in here. F of x is equal to x squared plus k, where k represents a number. So this could be x squared plus 5, x squared minus 2, whatever number attached to that x squared. We also have f of x is equal to x minus h squared. So what this first one does, and we'll talk more about that later, is this is going to move our graph either up or down, depending if it's positive or negative. Okay. The next one, where we have x minus h squared, tells us that we are going to take some value and either move that graph from the left to the right. So this value here, this minus h, tells us that we're moving left or right. Okay. We have another form, which is f of x is equal to a times x squared. Okay, so that is if we have a coefficient in front of x squared. Okay. Again, that a value, h, and k value are all representing numbers that are going to manipulate our original parent function of x squared. And what the a does is it either stretches it or compresses it. I think that's how you spell compress. So what that means is whatever our a value, that coefficient in front, we're either going to stretch our x squared either horizontally or vertically. Actually, I like that better. Let me erase compress and stretch. Sorry. We're going to say stretch horizontal or vertical. So it's following the x and y axis. And then the last one, which is the most common, and it takes them all together, so all the a, h, and k values, and puts it into one equation. And this is the equation that we're going to focus on here, and this is called vertex form. Okay, and we're going to find out later why it is called vertex form. But this is taking our original parent function, x squared, and either stretching it, moving it left or right, or moving it up and down. Okay, so we're going to then talk about each of the forms. I'll give you more information on what that means. Yes. So the first one we're going to focus on is f of x is equal to x squared plus k. And we're going to define a couple keywords here. And the first one is parabola. So parabola is another name for a quadratic graph. Okay. A parabola in this specifics of a quadratic graph could be either facing down or facing up. Okay. A parabola is not necessarily always a quadratic. It could be x cubed, x to the fourth, any type of x that has a numerical exponent. Okay, bless you. But for this course, we focus on quadratics. Bless you. Okay, the vertex is going to be the highest or lowest point on a parabola. Okay, so if we have it facing down or facing up, it's either the highest or the lowest. We have other names for that, and it is called the maximum versus the minimum value. So in terms of just quadratics, we call that the vertex because that is the point where the parabola changes directions. So for example, notice how this is starting to go up and then it turns and goes back down. Okay, this one is going down, it turns, then goes back up. Okay, vertex is where it changes directions. We then give it a name, maximum or minimum, because later on when you start talking about higher order parabolas, there could be multiple maximums and multiple minimums. Okay, and then we have axis of symmetry, which from here on out I'm going to refer to as AOS instead of having to write axis of symmetry every time. Okay, and this is a vertical line that passes through the vertex and shows us where we have symmetry on that graph. So recall that symmetry means that if you were to take, let's say, a graph or a paper or anything, right, fold it in half, it should be the same on both sides. Okay, so you can put that in parentheses, symmetry, but we should remember that because it's in the name, axis of symmetry. So if you were to see this as a diagram, we would have our parabola opening down and then opening up. We have our vertex, which is either the maximum or minimum value. And then we have our axis of symmetry, which is a line that goes through the vertex. And if we were to take that line and fold that graph in half on that line, we should be symmetric on both sides. It should be even or the same on both sides. Okay. So remember I said that K value is going to either tell us that we're moving the graph up or down. That is called a vertical shift, right? Because vertical means we're going up or down. So if K is positive, so if it's greater than 0, then we're going to shift up K units. Okay. If K is negative or less than 0, then we're going to shift down K units. Okay, we're talking about direction here and distance. So that's why it has the absolute value of K, because we can't go a negative distance, or travel a negative distance, I should say. Okay, all you need to remember that if K is positive, we go up. If K is negative, we go down. Okay, any questions so far? Okay, so here we have some examples. Not ones that we have to solve because they do this for us. But notice that we have a parabola. The parabola is opening down, which means this point at the top right here would be our vertex. So I'm going to label that vertex. Would it be a maximum or a minimum? A maximum. So I'm going to put max in parentheses. Okay, here we notice that, let's see. We have our axis of symmetry, which is going straight through the vertex. And notice that they label the axis of symmetry x equals 1. Well, x equals 1 is also our x value of our vertex, because we could give this a value. So if we were finding the vertex as a point, we would notice that this is 1, 2 on the graph. 1 because it's in between 0 and 2, and then 2 because it goes up to 2. And so when they label x equals 1 as the axis of symmetry, that's to say if we were to draw a line straight down the middle, it's going to be symmetric on either side. Okay. And then here we have, I want to actually show one more thing here because I didn't mention this at the top. This a is less than 0. Remember on one of our types of quadratic forms, we had f of x is equal to a times x squared. And I tell you that can lead to a stretch, vertical or horizontal. Well, that a value also tells us if our parabola is opening up or down. So this says a is less than 0, and our a value is right here. It's that -1. Since our a is negative, that's why it's facing down. Say that again?
Oh, there's no name to it, correct? Vortex.
No, the one that I'm talking about, just the a to the x squared, doesn't have a name. The only one that has a name is that last one, and that's vertex form.
Is this vertex form?
The one that they gave us is actually standard form. Because remember, that's ax squared plus bx plus c. We talked about it in the beginning of the course.
Is the vertex only going to be on the x-axis?
What do you mean on the x-axis?
Is it only going to be straight?
Oh, I see. The axis of symmetry. Yes, the axis of symmetry is always going to be a vertical line.
Wait,
yes.
So you said since it's a negative, the a is going to be down?
Yes, that's why the graph was facing down.
Oh, okay, I get it.
Mm-hmm. Okay, so on this one, you'll notice that some things are opposite here. We have a is greater than 0, which means a is positive. Well, in this case, our a value is what? Positive what if we don't see a number? 1. It's a positive 1 right here. Okay, this is telling us that it's going to face up. We have our vertex at the bottom this time at what point? -2, -9. Okay. That is why our axis of symmetry is x equals -2, because it's always the x value of the vertex. So again, this is the axis of symmetry. We have the vertex. We labeled A, and that's why it's facing up. And then the last thing, this vertex, would it be a maximum or a minimum? Minimum, because it's on the bottom. Okay. So your examples are not going to look like this. It's more to show you the A value. If A is positive, it's facing up. If A is negative, it's facing down.
The parabola, right?
The parabola, yes. We're going to talk about that with each part. And the reason why we saved this for the end of the course is because we're going to need all our factoring skills, all of our radical skills, rational skills, everything we've learned up to this point, we're going to need to put this into vertex form. And when we're in vertex form, then we'll be able to see what that, for example, 4x will do.
It's kind of confusing because it says -5 at the end, right? And it's supposed to, or the k value is supposed to control like the height of it. So why does it go down to -5?
Correct, and that's because of this plus 4x. So we can't look at this equation and say this is the k value until we put it in vertex form.
Okay.
Yep, so if it's in standard form, right, this is not k, this is c. Okay, so that's why it's not telling us which way we're going. Okay. Instead, what that -5 is telling us, that C value, it's telling us the y-intercept. And the y-intercept is right here at -5. Don't worry though, we'll get to all of that.
What is this at the bottom? AOS.
AOS, axis of symmetry.
Now I understand.
Okay.
Because vertex
What?
one would be the K, where K value would tell you whether it goes up or down.
Yes,
Got it.
yes. Was everyone done writing this?
Yeah.
Okay, okay.
Oh, I just one on the first. Oh, you just read out standard.
I just wrote out what standard was, yes.
X squared plus bx.
Yes, and that's not too important in these notes just yet. We might talk about that more on tomorrow's notes, the last one. Okay, so in the example here, it says graph the following functions on the same coordinate plane. So it gives us the function f of x equals x squared. This is our parent function. That means it has no other a, h, or k value that's manipulating that function. Okay, that's standard function that you usually start with before you start adding the manipulatives. Okay. This next one, we have x squared plus 1. Notice now we no longer have a middle value. We don't have that b value anymore. So this is our k value, right? Because we don't have that middle value anymore. This is our k value. So this plus 1 is telling us that we're going to go up 1. And the -2 is telling us we're going to down 2. So in order to figure out how to graph this, we're going to have to create a table of values because we can't just guess and see where the parabola is going to be. So when doing those table of values, usually for quadratics, we want to pick at least 3 values. We want to pick a negative number, 0, and a positive number. And it doesn't matter what those numbers are. What I like to do to make it easiest is just pick -1, 0, +1. It's easy to plug in those numbers. So in creating my table, I'm going to create every function in there and plug in those values. So I have f of x is equal to x squared. G of x is equal to x squared plus 1. And h of x is equal to x squared minus 2. Okay. So what I'm going to do is I'm going to replace the x with each of those numbers. So I have -1 squared, which is 1. 0 squared is 0, and 1 squared is 1. And I'm doing that for every single one. So those are my values for f of x. And now I'm going to plug into g of x. So this is -1 squared plus 1. So this is 1 plus 1, which is 2. Then I have 0 squared plus 1, which is 1. Right, square 0, I get 0. 0 plus 1 is 1. What would I get when I plug in 1?
1 for
2, right? 1 squared is 1. 1 plus 1 is 2. Now I'm going to plug it into h of x. So I have -1 squared minus 2 this time. So that's 1 minus 2, which is -1. Right? And if we can't do this, we have our calculator. And then we do 0 squared minus 2, which is -2. And then we have 1 squared minus 2, which is again -1. So this was my values for f of x. these were my values for g of x, and these were my values for h of x. So what I'm going to do is I'm going to use those values and plot the points. So notice my x value is this number, no matter which one I plugged it into, which means I have the point negative 1, 1. Okay, I have the point negative 1, 2. And then lastly, negative 1, negative 1. When I plot these, however, I want to plot them by the function. So I'm going to plot all of those points first, and that's going to give me my first function. So I'm going to do that. That's my parent function. Okay, so I have negative 1, 1, 0, 0, and 1, 1. Okay, notice when I did positive and negative values, I know I'm going to get that U shape. Okay, so this is going to be my f of x function. Then I'm going to do my g of x function. So I'm using negative 1, 2, 0, 1, and 1, 2. And notice when I plot this, what you're going to see is that my entire function moved up. I moved up 1. Then I'm plotting my h of x function, and that's negative 1, negative 1, 0, negative 2, and 1, negative 1. So when I graph this one, I notice that the whole parabola moved down 2. So this is to show you that that k value does indeed move up our parabola either up or down based off of the k value being positive or negative. Okay. Any questions on the first example? Okay. So now on this example, it just wants us to plot.
This,
Yes.
could you go back up for 1 second?
Yes. Yes, here we go. So if you want to try the next one, while we wait, we're just graphing that one equation. And you're going to notice that when we plot those points, your parabola should be going up or down? Down.
So how do we know if we're doing g of x, f of x, or h of x?
What do you mean? Like for the next example?
Yeah.
So you're only going to graph the one it gives you. So now you're doing m of x. Just this one right here. So you're going to just plug in the same x values into that and see where it goes. So you're not graphing all three on this one, just one. Okay, so we said this is going down 4. And when we say we're moving up or down, that's from the parent function, right? From the parent function. If it doesn't ask you to graph the parent function, you don't have to. So in this case, it's only telling you to graph x squared minus 4. So I'm going to create my table. And if I wanted, I can pick the same three numbers. I could pick -1, 0, and 1. The only importance here is to make sure you choose a negative number and a positive number. Okay. So when I do this, I'm going to plug in -1 and for x. So I have -1 squared minus 4 which is 1 minus 4, which is negative 3. Then I have 0 squared minus 4, which is 0 minus 4, which is negative 4. And then 1 squared minus 4 is going to give me negative 3 again. Remember when we talked about axis of symmetry, we said that this shows where it's going to be the same on either side. So it makes sense that if we plug in the same number, but we change the sign, we should get the same answer back. So when we plugged in negative 1, we got negative 3. And when we plugged in positive 1, we still got negative 3 because we're trying to form that symmetry on both sides. Looking at this function, before I even plot those points, is this going to be facing up or facing down? Up. How do you know it's going to be facing up?
Because the A value is positive.
The A value is positive, and what is the A value?
1.
1. Good, so we know it's going to be facing up. So then I'm going to take these points, so negative 1, comma, negative 3, 0, comma, negative 4, and 1, comma, negative 3, and plot them on my graph. Okay, so negative 1, negative 3, 0, negative 4, and then 1, negative 3. And then I'm going to draw that parabola. It's very important that you don't just do this. Don't just connect this and make a little U at the bottom. Because what we're doing is we're only finding some points. We could technically find all of these points, but that would take a long time doing all that math. We only need 3 to draw it. Just make sure when you draw it, you extend it all the way up and draw your arrow. This tells us that this can go on forever. Okay. Obviously, the more points that you plug in, the more x values, the more accurate your graph is going to look. Okay, because when I get to this part up here, I'm kind of just guessing based off of everything. I'm going to assume it goes like this.
Like we should not go straight up the line.
Correct. It should have some type of curve up.
I caught myself because I'm
Okay. Okay, so the next one, we're going to do the same thing. But notice we have a fraction. When we're graphing, we don't like fractions. It's easiest just to convert that to a decimal. So if you were to plug that into your calculator, 7/2 is equal to what? 3.5. So when you're using this, technically, just use n of x is equal to x squared plus 3.5. So any other time, we prefer fractions except when we're graphing. Okay, and since it's a positive 3.5, that tells us that our graph is going to move up, right? It's not going to be at the origin where the parent function usually is. It's going to be up 3.5 units. Is our graph going to be facing up or facing down?
Down.
Facing up. Why?
This, like the bronze
Mhm.
Yes.
Yes, facing up, like where you draw the arrows. The arrows point up, so it's facing up. If the arrows point down, it's facing down.
The A value.
So it is going to be facing up because of the A value, and the A value in this case is what? 1. We don't see it. It's not there, so we assume it's a positive 1. If it's a positive A value, it's pointing up. Okay. So then you still plug in your x values. And just to show you that it can be other numbers, I'm going to plug in -2, 0, +2. And so I have -2 squared plus 3.5. That is equal to 4 plus 3.5, which is 7.5. Then I have 0 squared plus 3.5, which is 3.5. And then without even plugging this in, what do you think the answer is going to be?
0. Wait,
For 2, plugging in 2.
3.5? Oh no, 5.5?
7.5. Because remember, our parabola is symmetric. So whatever we do on the negative side is going to be the same that we do on the positive side. So no matter if we plug in a -2 or a +2, we're still going to get 7.5, and that's because we are squaring that x value.
What did the negative 2?
I made them up. You can pick any x values you want. You could put -1,000, +1,000, right? It doesn't really matter as long as you pick one negative, one positive.
So I solved it using, I did most of it using -1, 0, 1 already.
And you're going to end up getting the same thing that I do.
Alright.
Maybe not my initial points, but my graph when I draw it.
Yeah.
Okay, so I have -2, 7.5, 0, 3.5, and 2, 7.5. So I'm going to plot those. So -2 and then +7.5. 2, 3, 4, 5, 6. Okay, right here. And then 0, 3.5. 2, 3. And then 2, 7.5. Okay, so if you chose different numbers, your points probably don't look like this. But once I draw this, it should look similar to what you drew. So if you plugged in 1 or -1, I'm assuming you probably got around 5.
3.5.
Yes. Okay. Yes. Around there.
So what is important is the shape, or like the dimensions, as opposed to where it's at.
Or the vertex.
What's important is that it's symmetric, right? So if, for example, if you're choosing -2 as one of your x values, I would choose +2 as the other one.
Right.
Okay, so make sure it's symmetric. The other important part is the vertex, and where's the vertex here?
3.5.
Well, remember, it's always a point. So this is vertex at what point? 0, comma, 3.5. Okay, that's why we're choosing 0, because for these basic ones that are only moving up and down from the parent function, I know the parent function is at the origin. Okay, so that's why I'm choosing 0. So I know it's going to either move up or down from the origin. And then if we were looking at this further, what would be the axis of symmetry as an equation? X equals 0, right? Because it is always the x value of the vertex. So in this case, the vertex is 0, so our equation for the axis of symmetry is x equals 0. It's not the same as just saying 0. Those are two different things. Because we're trying to form a line, the line that shows the symmetry on the parabola. Okay. Any other questions on this concept? Okay. So now we're looking at the second concept, and remember that concept was if f of x is equal to x minus h squared. So now we're looking to see if it's moving left or right. So moving up and down was a vertical shift. What do you think left and right is?
Horizontal.
A horizontal shift. So this is a horizontal shift. So if h is positive, then we are going to move to the right. If h is negative, we are going to move to the left. However, when we look at our equation here, notice that it's always minus h.
So would it be
So if you want to think of it that way, that's what I would do, because technically this is saying just this h. So if h was negative, really we would be seeing plus h, because minus a negative is a positive. So what I would remember instead, if we have minus h, we move to the right. If we have plus h, we move to the left. This would be the easiest way to remember it versus remembering that there is a minus in the formula. So think opposite. Okay. So in this example, you'll notice this is another example where we're starting off the concept. I'm going to have you always graph the parent function and two variations of the other function so you can see the shift. But normally you are not asked to graph all three. So again, this is the parent function. Since this is a positive h value, plus 1, which way are we going to move? Left 1. And since this is a negative h value, we're going to move right 2. So we're going to do the exact same thing, okay, as we did before. And you could continue to use -1, 0, 1, or you could use other numbers. It's completely up to you. So I'm just going to continue using -1, 0, 1. And I'm going to plug this in for the parent function, g of x, and h of x. So for f of x is equal to x squared. So this is -1 squared, which is 1. Then we do 0 squared, which is 0, 1 squared, which is 1. Those are all of my points for the first function. So if it helps, we could also stop there in our table and graph this one first. So if I was to graph this, this would be -1, 1, 0, 0, 1, 1. There's my parent function. Then I could go on and continue with g of x. That way I'm not confusing all of those numbers. So either way that helps. So g of x is x plus 1, then we square it. So this is -1 plus 1 squared, which is 0. -1 plus 1 is 0. 0 squared is 0. Then we have 0 plus 1 squared, which is 1. And then we have 1 plus 1 squared, which is 4. 1 plus 1 is 2. 2 squared is 4. So then I can plot all those points. So I have -1, 0, 0, 1, and 1, 4. 1, 2, 3, 4. So notice here, it didn't give me what looks like my U shape because I don't have part of that function that would extend to that -1. We just need to remember that this is supposed to look like a U. So when we draw this, we need to make sure we show that. So it would be something like this. And we just said g of x is going to move to the left 1. And if we look from green to blue, did it move left 1? Yes. Okay, so then we have h of x, which is x minus 2 squared. So we have negative 1 minus 2 squared, which is negative 3 squared, which is 9. Then we have 0 minus 2 squared, which is 4. And 1 minus 2 squared. 1 minus 2 is negative 1. Negative 1 squared is positive 1. So this is another one where we're not even getting close to the origin, which makes sense because we said this whole thing was moving to the right 2.
Oh, for that one.
Yes, because we're on the h of x this time. Okay, so then we have negative 1, 9. So negative 1, 9. Then we have 0, 4. 1, 2, 3, 4. And then we have 1, 1. So notice we're actually sharing a point with that green right there. Okay. Are we going to consider this point the vertex? Are we going to do this? Yes or no? No. Right? Because we said we're only moving which direction? Right. What does this imply we're also doing besides moving right? Moving up. And are we moving up?
No.
No. So you need to make sure you come down and touch that x-axis. So this would go down and touch it. I mean, a little better than I did it. Make sure it touches it a little bit more. Because we said the only thing that's happening is that it's moving to the right. We never said it's moving up or down, so we can't treat that as the vertex point. So if we wanted to be even more accurate, we wanted to know what those exact values are, we would have to continue to plug in different x values. Okay? And so for g of x, since it moved towards the left, we would have to plug in more negative values to see where it goes. And for h of x, since it moves to the right, we would have to plug in more positive x values to see where it goes. Okay. You can go ahead and try the next one if you're already done writing this down. Okay. We have a minus 7. So that tells us we're going to move what direction? Right. How many? 7. Okay, so once you're done writing down this example, you're trying the next one. And then if you feel confident in that one, you can do the other example, and then we'll go through both. Yeah. It's okay. I'm not going to grade you on how straight or curved your lines are. As long as it looks like it's following the correct path it should. Okay, I'll give you guys one more minute. Again, you're trying to do both of the examples that are after.
Figuring there's 1 minute to do both.
Well, I mean, it's been like 2 minutes already. 1 minute, maybe. It should be like 1 minute each. No, is that not enough time? No.
So, I did -1, 0, 1, and I got 64, 49, 36.
Yeah, was that one?
Yep, that's fine.
Okay.
Which means, can you just count up on the lines like we've been doing? Like, can you say this is 1, 2, 3, 4, 5? And would you ever get to like 64? No, so you have to label it either by fives. So you could say this is 5, 10, 15, 20. Okay, whatever makes the most sense. For this one, it may be easiest just to go by tens. If you just go by 10, so you would say 10, 20, 30. So the first one would be somewhere around here. 40, 50, 40. So between 40 and 50, and then right after 60. Since this is a sketch, it's not a rough sketch, it is a sketch. I'm not going to be too picky about how you're doing that, right? I'm not going to make sure that you counted correctly and plotting it in the correct point, as long as it's in the general direction. Just make sure you graph 64 higher than 49, right? Because it's greater. Okay, I'm going to go ahead and go through this first example with P of X. So we said that it's going to move right 7 because it's -7. Okay, so I'm going to set up my table. And again, how you set up the table could be different. You could use different numbers. So I'm just going to use -1, 0, 1. My equation is x minus 7 squared. So that's -1 minus 7 squared, which is -8 squared, which is 64. Then I have 0 minus 7 squared, which is -7 squared, which is 49. And then I have 1 minus 7 squared, which is -6 squared, which is 36. So those numbers that you got were correct. Okay, and since they are such large numbers, again, I am going to go ahead and assume each of these lines are going by 10. So 10, 20, 30, 40, etc. I'm going to make sure my x-axis is still going by ones. So when I plot this, I am going to have -1, 64. So -1, 10, 20, 30, 40, 50, 60. So somewhere over here. 0 and 49, so 10, 20, 30, 40, right before 50. And then 1, 36. 1, 2, 3. That's a great question. Is it opening down or is it opening up? Up. How do you know?
So the A value is positive.
The A value is positive. And what's the A value in this case?
1.
1. So that tells us that this is not going to be our vertex. We don't need to draw it like this because we didn't continue to pick points to see if it even hit the origin. Okay, and our goal here is that it just moved right 7. It didn't move up or down. So it should be touching the x-axis when we draw our picture. Okay, so this should look like something like this, a very wide parabola. And that is because, again, from the parent function, we only said that it moved right 7. Okay, did I even draw that? Let's see, 1, 2, 3, 4, 5, 6, 7. Technically, it should hit right here. I'm going to redo that. 1, 2, 3, 4, 5, 6, 7. Okay. Yeah, technically, it's going to look something like that. So it should have moved right 7. Okay. Of course, if you made yours a little skinnier, a little wider, that's not important at the moment. Okay, just that it moved right 7. So on the next one, notice we have a positive 1.6.
Quick question.
Yes.
Do you have to label the vertex and label?
Only if it asks you to.
Okay.
So in these examples, not yet. On tomorrow's notes, you will be asked to label everything, and that will be on test 5. Mhm. So here, we're just breaking it step by step. So we're building up to what's actually going to be tested in the next course. You're never going to see a simple equation like this. You're always going to see it in vertex form. So what we're doing is we're breaking apart each step. So when you see a vertex form equation, you're going to know how to identify A, H, and K and what that means. So here we have plus 1.6. So that means we're moving where? Left 1.6. Okay, so again, I'm making my table for Q of X. And I'm still just going to plug in the same numbers. I could change it up. I could change it to -3, 0, +3. Okay, you could choose any numbers. So if I plug this in, I have X plus 1.6 squared. So sorry, go ahead. Q of X. Q of X. Yes, I do. Many people do this at the end of the Q, so you don't confuse it for a 9. Yeah, because if you just do that, because this is how I typically write my Qs. But yeah, got to add the fancy tail. Okay, so -1 plus 1.6 squared. -1 plus 1.6 is going to be 0.6 squared. And if you type that in your calculator, what do you get? 0.36. So now instead of having very large numbers, we're going to have some small numbers. Okay, then plugging in 0, we have 0 plus 1.6 squared, which is the same as saying 1.6 squared, and you should get 2.56. And then plugging in 1, we have 1 plus 1.6 squared, which is 2.6 squared, which is 6.76. So these would be the points that I'm plotting now. And when I graph this, the end goal here is that I should see a parent function that has been moved to the left. So I'm going to plot these points. I have -1.36, so it's just going to be a little bit above that 0. Then I have 0, 2.56, so 1, 2, 2.5. And then I have 1, 6.76. 1, 2, 3, 4, 5, 6, so somewhere around here. Okay. So I know it's going to move to the left only 1.6. So it should hit somewhere around here, right? Because that's a little bit more than 1. So when I draw this, and draw it like that. Try to make it as symmetric as possible on both sides. Any questions on that concept?
Did you point the dot of 1.6?
Sorry, say that again?
Did you put a point on the north vortex?
Yes, I placed that dot there. Just so when I was drawing it, I know where to connect it down to that x-axis. Okay, so we've moved it up and down, left and right, and now we're going to talk about our a of x squared. So that vertical, so a stretch vertically, a stretch horizontally, and then where it opens up or down. So it says, well, let me first write the equation. This is f of x is equal to a of x squared. So it says if a is greater than 0, which means it's positive, we know it's going to move up. So if it's greater than 0, it's going to move up. Okay. If it's less than 0, we know it's going to open down. So those are the big things here. Okay, positive or negative, opening up or opening down. And we kind of talked about that already. The other things we have here is if a is between 0 and 1. Okay, so if a number is between 0 and 1, what kind of number is it? Between 0 and 1. If we have a number between 0 and 1, what kind of number is it? A decimal or a fraction, right? A decimal or a fraction. So I'm going to write that. I'm going to write fraction. And I'm going to write proper in parentheses. Okay, what do I mean by a proper fraction? It's a simplified fraction, and the numerator should not be larger than the denominator. Your denominator should be larger. An improper fraction is when the numerator is larger. Like say if we have like 26 over 5. That's improper. Okay, so if we have a proper fraction, so between 0 and 1, then we know the graph is going to be exactly the same as the parent function with a vertical shrink. Okay, vertical shrink. Sure, they use the word shrink. So what this means is if you have a rubber band, so if you pretend you have a rubber band in your hand, right? If we were to stretch that rubber band vertically, this would be a vertical stretch. If we were to shrink it, then we would bring the rubber band closer to the origin, which means the sides would get larger. So we're going to have a fat parabola. Okay. If a is greater than 1, so here's the next part. So no longer a fraction. But if a is greater than 1, then we're going to have a vertical stretch. So that's you taking your rubber band, stretching it apart, which means your parabola is going to get fat or skinny? Skinny. I'll even write that in parentheses here. This is a fat versus skinny. Or if you want to say small versus wide, if you don't want to write fat versus skinny. Okay, so then looking at our negative ones. If we have a negative a value, that is again a fraction. So a fraction between 0 and 1. Not only is the parabola going to face downward, it is also going to have a vertical shrink, which we just said vertical shrink means the graph gets
Skinnier.
fat.
Yeah.
And if our a value is greater than 1, and I know that sounds a little crazy because we just said a is negative, but what it's talking about is if you were just looking at the a value, so regardless if it's negative or positive, if that a value is greater than 1, then we have a vertical stretch, which means skinny. So what do you notice here? Which ones are the same, even though the wording is different? So
Between 0 and 1.
this one is the same, right? So no matter if we have a fraction, okay, no matter if it's positive or negative, it's still going to make a vertical shrink, which makes the parabola fat or wide. Okay, and then these ones are the same. So no matter what, if it's positive or negative, if the a value itself is greater than 1, then we're going to have a vertical stretch, which means we have a skinny graph. Okay. Typically, they label this as horizontal and vertical stretch. So when you see a vertical shrink, another name, and I'm not sure if you'll maybe, let me rephrase that. This thing, when you were in college algebra, is typically referred to as a horizontal stretch. That's why I put horizontal and vertical in the very beginning. Yes.
For number 2, does it also have to be a proper fraction?
Yes. So when you see the word vertical shrink, that could also be same as saying a horizontal stretch. So I'm not sure if also Alex is going to rephrase it that way, so it's just good to have that vocab there. Horizontal stretch is the same as a vertical shrink.
So any fractions equal fat and anything greater than 1 equals skinny.
Correct. Okay.
What is better to use Alex in this program?
What's better to use than Alex?
No,
Who
who
decided?
decided?
Oh, who decides? The dean of the math department. I think. I don't know who decided.
I thought it was you.
No, it's not me. No, so like no matter if you were taking the class with me or someone else. No, because if it was up to me, I'd just give you, I would say, get this textbook and do it from the book.
Nothing to do with you.
No, nothing. I would prefer a textbook, but the reason why they make everyone in math 0320 use Alex is because Alex has that thing that says hint or explanation or show me in the book, versus if you just had a textbook, you can't do that.
Wow.
So that's why they use that. Is it better?
I don't think I've ever used it.
No?
No. I just felt-
It used to be McGraw-Hill,
Yes.
which is about as good as Alex. Right, so yes.
I actually had, on 2 different assignments, I had issues with Alex on one of the questions.
Was it the right angle one? What? Was it the right angle, right, a triangle with the right angle?
I don't think I've seen that one. If I have, I've already done it. No, because to answer it wants the equation, then the divide with something else in the bottom,
Uh-huh.
but it's not giving me the option to do that.
Hmm.
And no matter what I do, it's just marking it wrong. And then saying that equation with the divide and then.
You can always screenshot it, send me an email, and I can fix it. I can override it.
Very specific.
Yeah.
And
Yeah.
then that one on number 12 that I'm stuck on, this only one that I'm behind on is 12.
Mhm. Yeah, if you ever have issues, just screenshot it, send me an email. I'll override it, give you the point. I know there was a couple people who came to me, they put in the answer and then it's marked it wrong, but then it gave you the same answer back.
Oh, yeah.
Oh, yeah. That's
So just show me, right? I will override it. Yeah, it's not my favorite. Not my favorite. They used to, when I taught this course 3 years ago, because I took a little break between, when I taught this 3 years ago, they used to have you, instead of do Alex, I would give you a homework packet, like a big homework packet, and you had to complete that homework packet in the math lab. You were not allowed to complete it at home, only in the math lab. And then they had to sign off and give you hours. And in order to get the credit for the class, regardless if you got an A in the class, you had to have, I think it was 180 hours in the math lab for a 16-week course, right? This is an 8-week course, so it would have been half of that. For the same exact course that I taught 3 years ago here and at this campus. But they changed a lot of things in 3 years, so.
Everything they changed.
I'm thankful for that. I don't have the time to be here.
Well, I think they changed it for people who are taking classes like this because you have to work,
Yeah.
right? So how are you supposed to be in the math lab? Yeah,
I'm not gonna be here.
yeah.
I'm here.
I had people, when I taught last time, I taught a 5:30 in the morning class. By the time class was over, the math lab wasn't even open.
Yeah.
And so they had to wait here until math lab was open,
what time is it open?
I think 9.
It opens at
Yeah, and it was a 16-week course, so they only met 5:30, I think, to like 6:45. Like it was an hour 15. And so they had to wait 2+ hours for the math lab to open. I felt so bad, and I was like, sorry, it's not on me. You have to do it, right?
and it's because it falls or like 5:30 in the morning.
Yeah.
I'm
No.
on my way to work.
180
No.
hours. Are you sure it's 180 hours?
It was something like that. It was something crazy. But that was for a 16-week course. So like it was an 8-week course, it probably would have been 90 hours.
I'm supposed to be there in 16 weeks. And I-
Yeah. So I think they changed it because they're now adding a parent-friendly course, I think next year, that you are allowed to bring your kids to. So I volunteer to teach those so I can bring my my kids as well. No, any kids. They write, they say, are you okay teaching with infants in the room crying? Sure, why not? Like, are you okay with 5-year-olds running around while you teach? Sure. Yeah, but they're opening it for parents who are not able to come in, right? Who don't have the support.
For daycare, this and that.
Yeah.
Ms. Marco, what
Yes.
time do you start work in the morning?
Sorry?
What time do you start work in the morning?
I'm teaching like 11 hours a day.
Here.
Oh.
I get to work at 7:45. I come straight here. I get out of work at 5. So I drive straight here in the traffic, get here 5:30-ish.
7:45.
Yeah.
I've already been at work from.
And then I teach a couple hours now. So I'm teaching for like 11, 12 hours.
I feel bad.
Yeah. It's okay. I signed up for it. I chose to do it.
Just like
You know, in this economy, I need some money.
I chose to be here and lose money.
Okay. So sorry for whoever is going to be watching this recording back because we did a little pause of our chit chat, right? We still got a couple. This is a long notes. No, we're not done yet. We're not done. I was letting you guys have a mental break, right? Mental break, then we'll go back. We just went over the rules. We had to look at the examples. 10-minute break. That was our 10-minute break. We talked, we chat, we had good time. Now back to work. Okay. So where are we? Right here. Okay. So we're doing the same thing now, and then now we're going to notice that we're either going to get a skinny graph or a fat graph. So again, this is still the parent function. And then since we have a 2 here, it's not a fraction, so that means we're going to have what type of graph? Skinny. Sure, I'll put skinny. Yes.
On that h of x, does that mean you're going to multiply by the fraction?
Yes.
Okay.
So then this 1/2 tells us that our parabola is going to be fats. Okay, so we're going to show that here. And we are going to, let's see, we are now going to use different numbers just to show you that you can. So I am going to, you don't have to erase it or anything. If you use negative 1, 0, 1, it's going to give you the same answer. Okay. I want to have all these examples so when you go back to the test, you see all the different ways we were doing it. So for the parent function f of x, we're just squaring it. So this is going to be negative 3 squared, which is 9, 0 squared, which is 0, and 3 squared, which is 9. That never changes no matter which concept we're doing in this notes. X squared is just going to be squaring that x value. Okay, g of x is 2x squared. So once we square that value, we're going to multiply it by 2. So this is 2 times negative 3 squared, which is 2 times 9, which is 18. Then we have 2 times 0 squared, which is 0. 0 times anything is 0. And then we have 2 times 3 squared, which is 2 times 9, which is 18. And then h of x is going to be 1/2 times negative 3 squared. So that's 1/2 times 9. And since we're graphing, we want decimals. So I would do that on your calculator. What's 1/2 times 9? Or what's half of 9? 4.5.
Oh, wait.
And then if we do 1/2 times 0 squared, this is still 0. Anything times 0 is 0. And then 1/2 times 3 squared is 1/2 times 9, which we said was 4.5. So I want you to notice something here. And that's this, that the origin where we chose 0, did that change for any of them? No, because we're not moving up, down, we're not moving left, right. The origin stays the same, which means they're all going to start at that origin 0, 0. And they're either going to go and get wide or fat or go up and get skinny and tall. Okay, so starting with the parent function, I have negative 3, 9, 0, 0, and positive 3, 9. Okay, that is my parent function. Then g of x. Well, maybe I shouldn't have done 9 all the way up there. I'll go by what, 2s? By 5s? Okay, we'll go by 5s.
Why not 3s?
We can go by whatever number we want, right? We can go by 5s. That's okay. So if we do negative 3, 1, 2, 3, our x's can go by 1 still. And 5, so 9 would be about here. 0, 0, 9. So there's our parent function, which means this is how it looks like regardless. So we can't call this skinny or fat. This is what it is baseline. Okay, g of x is negative 3, 18. So 5, 10, 15, 20. So right here. Still 0, 0. And then right here. So it's going to be skinnier than our parent function. And of course, much prettier than what I did it, right?
Wait, what would that mean? Oh, never mind.
Because we're talking about 2. 2 is skinnier. Okay, and then h of x, we should have something wider than the parent function. So we have -3, 4.5. So -3, we're going by 5, so it's going to be a little bit below. Still at 0, 0, and then a little bit below. So when I draw this, this is going to be wider than my parent function. Okay, any questions on that example?
And this is just based off of A, right?
This is just A. When we get to the end of the notes is when we combine it all. So I'm like, we're only about halfway through the notes.
This is by far the longest.
Yeah, I
notes,
think
right?
so. Besides the very first one, I think we did. Okay. So this one is going to show us the same thing, but notice our A values in G of X and H of X are now both negative, which means they're going to be facing, yes, upside down. So I have my parent function. This negative tells me it's going to be down, and then the 3 tells me it's going to be fat or skinny. Skinny. You can think of it this way. If it's a fraction, say fraction starts with F, it's going to be fat. Fat starts with F. Fraction, fat.
Oh, we're just looking at the numbers?
Just the number, not the negative or anything, just the number. The negative tells us it's going down. Once we establish it's going down, the negative goes away. Then we're looking at the 1/3, which is a fraction, so that means our parabola is going to be fats. Okay, so we set up our table. And I'm going to continue using -3, 0, 3. So my f of x didn't change from above. So I can actually just go to the one above and copy down those answers. So 9, 0, 9. Because I'm using the same exact numbers, -3, 0, 3, and my parent function never changes. Okay, then g of x tells me I'm going to square my x value, then multiply by -3. So this is going to be -3 times -3 squared. -3 squared is +9. +9 times -3 is -27. Okay, this is still going to be 0 because remember, when we're talking about if it's getting fat or skinny, it's not moving from the origin. So it's going to be zeros across the board when we're talking about origin. And then next we have -3 times 3 squared, which is going to be the same -27 because of the symmetry. H of x, we are going to multiply x squared by -1/3. So -1/3 times -3 squared. -3 squared is 9. 9 times -1/3 is close, -3. And then we have -1/3 times 3 squared, which is again -3 because of symmetry. So that's why I chose -3 and 3, because I know we would get pretty numbers here. But it doesn't matter. If you get decimals, that's okay. You just plot those decimals. Okay. So when I'm graphing this, the thing that you're going to notice is that my parent function is going to be the only function facing up. The rest of them are going to be facing down. So graphing this, what number do we want to go by now? 3, that works. So -3, 1, 2, 3, 3, 6, 9. 0, 0. And then 1, 2, 3, 3, 6, 9. That's our parent function. Parent function is going up because it's not negative. Parent function never changes. Okay, then we have g of x. So that's -3. And then notice we're going down now to -27. So 3, 6, 9, 12, 15, 18, 21, 24. Oh, look, perfect. Right here at the bottom. 0, 0. And then 1, 2, 3, all the way to the bottom. Okay, so this is facing down, but it's still going through the origin. Okay, and notice it got skinnier. It's not as wide as the parent function. And then I have h of x, which is -3. So 1, 2, 3, -3. 0, 0, and 3, -3. And so this one is going to go down and be wider than my parent function. Okay, any questions on this concept? Because now we're going to take everything we just learned in the first 3 concepts and combine it into one equation, and that is the vertex form equation, and that's the one you're going to see in college algebra. Okay, so we're going to have to be able to do all of these traits in order to manipulate our parent function. So this is called vertex form. And vertex form is f of x is equal to a times x minus h squared plus k. Now we have everything. We have our a, our h, and our k. So this is when we start talking about the vertex, axis of symmetry, and maximum and minimum values. So we kind of did this a little in concept 1. The only thing I'm going to write here is that our vertex is h comma k. So the reason why this is called vertex form is because we can easily find the vertex in this form. Mathematicians aren't very clever, right? So again, vertex form because we can find the vertex. The vertex is h comma k. So for example, if this was 2 and 5, in replace of h and k, our vertex is 2 comma 5. We don't have to do any math or any tables to find that vertex.
So if it's like x plus 3,
Mm-hmm.
so that x is going to be something like a -3.
Mm-hmm. Yep, so it'd be -3 comma, let's say that's 5.
Yes.
Yes. Okay. Our axis of symmetry is x equals h. Makes sense because axis of symmetry is always the x value of our vertex. And if our vertex is h comma k, this is x equals h. So whatever h is, that is our axis of symmetry. Then it talks about if we have a maximum or minimum value, but we talked about that in concept 1. Okay, so out of everything that we did on this notes, these examples here are what's going to show up on the test. Okay, so I'm not going to have it broken down on the test. You're just going to be given a vertex form, and you're going to have to answer the following questions exactly like this. You have to graph it, find the vertex, AOS, Determine if it's a maximum, min, domain, and range. Yes.
So for this one, the vertex would be 3, and then, or 3 and 4.
Correct. So this is 3, comma 4. Axis of symmetry would be,
3,
but remember it's not just a number, it's an equation. So it's not x minus 3. X equals 3. Okay, if you just write 3, it's going to be marked wrong because it's an equation. We're trying to find the equation of the vertical line that makes this symmetric. Okay, how would I know if this is a maximum or a minimum? If positive or negative a value. So our a value is 2. Is that positive or negative?
Positive.
Positive. So it's going to be facing up, which means we have a minimum. It's always opposite. And that's all you have to do for that one is circle if it's max or min. You don't have to tell me exactly what it is.
So it would be 2, but it
So
would be
wait,
min.
min is minimum's up, maximum's down.
Because the vertex is at the very bottom.
Yes, so it's wherever the vertex is. So if your parabola is facing up, that means your vertex is on the bottom, so it's a minimum. If your parabola is facing down, your vertex is on the top, so it's a maximum.
Okay.
Mhm.
So the main would be all real numbers and the range would be, bracket,
3.
4, comma 10.
Yes. Okay, so for the domain is always, on these type of problems, always all real numbers. You will never have to guess at it. It's always all real numbers. Range is going to be determined on if this is a maximum or a minimum. So since we said it's a minimum, then we know that it's going up towards infinity. Okay, so that's how he was able to get this part, to infinity. The first part is always going to be that k value, which we said was 4. So it's going to be bracket 4 to infinity. Okay, so if I'm color coding this is where this came from. Okay, and this is where this came from. And we know this is a minimum because it's a positive a value. So what's nice about this is that we are able to use the information we found to graph this. Okay, and if we need any other information, we'll just create a table. So the first thing I'm going to do is I'm going to plot the vertex. So that's at 3, 4. Okay. The axis of symmetry goes straight through that vertex. Typically, they do it as a dotted line because we don't want to get it confused with our function. Okay. And we know that this is facing up. So if you just did this,
This is gonna be
yes, if you just
4 to the right, right?
4 to the right, yes, okay. So this is 3 to the right, that's correct, and this is 4 up. And when we plotted that vertex, we got that exact thing. We went right 3, up 4.
Okay.
And so this is just us creating that symmetric parabola on either side. Okay. You're only asked to graph a sketch. If it wanted to be something that was exact, it would tell you to create a table to get exact values. But the most important thing on this is this part. If you can understand this part, you can use the vertex and axis of symmetry and the max or min to determine which way your graph is going to go and where it's going to start. So there will be questions exactly like this on the test on Monday.
Does it matter if it's fat or skinny, or we're just answering?
Yes, you could write that. So this is a 2, and so this 2 tells us it's skinny. All right, but since we didn't graph the parent function here, we don't have anything to reference it to. So I just would make sure you don't make it super wide.
That's what that was gonna be my question.
Correct. And also because, again, we're just sketching a graph. We're not drawing an exact, precise graph.
And the 3 is positive.
Yes,
Why?
because we always look at the opposite. So since it says -3, we do the opposite, +3. So if that was a +3, then we would write -3.
And what about the 4? Doesn't work?
The 4 stays the same. It's a +4, so we write +4.
Oh.
Only that h value changes opposite sign.
So, the -3, that would be for the vertex, it would be positive, right?
Correct.
You're saying,
Correct.
okay,
Mm-hmm.
okay.
Okay, let's look at the last one. Yes, the last example. Okay, so if you want to do that first, that would be a great thing to start with. Is just look at this function and label everywhere that it's changing. So this negative tells us what?
A maximum.
It's going to be a maximum because it's facing
Down.
down. Do we have any other a value besides that negative? So technically a 1, right? So is this going to determine if it's fat or skinny, or is it just normal? Normal, right? We don't have anything determining fat or skinny. What does this +2 tell us?
The negative will go to
What, the left 2. And what does this -7/4 tell us?
It's gonna be a negative 1.75. Oh, it's gonna go down 1.75.
Down 7/4.
Do we have to turn it into a decimal or?
Yes, it would be easiest to graph a decimal. So does someone want to put that on the calculator? What's 7/4? Say it again. 1.75. And it's -1.75. Okay, that would always be a good place to start. And then you can use that information to fill in the rest. So the vertex here is going to be what?
-2,
-1.75, or you could write -7/4. That's fine as well. Just when you graph it, it's easier to do decimals. What would be the axis of symmetry?
x equals -2.
X equals -2.
Where did the negative 2 come from?
Because it's always opposite of this h value. So if it's a +2, we write negative because it's going left. Is this maximum or minimum? Maximum because it's going
Down.
Domain is always what?
All real numbers.
All real numbers. And then range is going to be depending on max or min. So last time it was min, we went to infinity.
Be negative.
Now we're going to a negative infinity. That's going to be our smallest number. So it's going to be negative infinity to what? -1.75. Always a bracket because that's where the vertex is. And it's a solid line. So it's always included. So if it's a maximum, we start with that negative infinity, go to our k value. If it's a minimum, we start with our k value and go to infinity. And then we can try to plot this. So we know that this is going to be -2, -1.75. So the vertex is somewhere over here. Our axis of symmetry is this way, and we know it's going down. So it's going to look like this.